Hello guys, welcome back to Math with Trockers. Okay, today we are talking about probability. What is probability? It is just the chance of an event happening. Okay, when the probability is 1, just know that the event will definitely occur. And if it's 0, that's an impossible event. Right. When the question says given that, it simply means we are only focusing on a particular outcome. And this is called conditional probability. What is conditional probability? Conditional probability, it is the probability that an event will happen given that another event has occurred. So for example, one would go to advanced level given that they pass their ordinary level. Right. So with that being said, today we are focusing on probability from ZIMSEC, June 2007, paper 2. The question reads, a manufacturing plant uses 3 machines, A, B, and C, in its production process. The machines contribute 40%, 45%, and 15% respectively to the total daily output. It is known that 4% of the bulbs produced by machine A are defective, 3% of those produced by machine B are defective, and 1% of those produced by machine C are defective. A, find the probability that a bulb chosen at random from the day's production is defective. B, given that a randomly chosen bulb is defective, find the probability that it was produced by machine B. Right. So guys, if you want to be successful with conditional probabilities, we need to come up with a tree diagram. So let's see how a tree diagram works. All right, so in this case, there are 3 machines. Machine A, right? So we have, okay, this is number 11A. So, okay, before we even talk about A, sorry. Okay, we have 3 machines here, right? We have machine A, machine B, and machine C, right? Okay. Then for the 3 machines, the machine A will contribute 40% of the total daily output. So this one is 0.4. Machine B is 45%, so it's 0.45. Machine C is 15%, so it's 0.15. Then, as we can see, each machine will produce defective products. So let D be an event that the product is what? Defective. Then I can say D bar, it means it's not defective. And again, we do the same for B. We have D, not defective, defective, not defective. And only 3% from A are defective, so it's 0.03, meaning to say 0.97. Okay. Then for for A it was 4%. Okay, I'm sorry about that. Let me quickly fix this. All right, so for A it was 4%. Okay, 0.04. So here 0.96. Then for B is 3%, 0.03, 0.97, and only 1% for from C. So 0.01 and 0.99. Right. So the outcomes will be from A, defective, A, not defective, from B, defective, not defective, C, defective, and not defective. Now, we want to find, so for item A, we want to find the probability that the bulb chosen at random from the day's production is defective. So when a bulb is defective, we don't know where we don't know the machine is coming from, right? So probability of defective here is it's either coming from A or it's coming from B or it's coming from C, right? Here it was supposed to be just this, not C bar, right? So C, D, right? So in probability, when you see the word or, simply means that's the union. It's either one or two events, one or both events will occur at the same time, right? But here, if you see the word or, I'm going to add, and means I'm going to multiply. That's the intersection, and they will happen at the same time. Okay, so now it's going to be probability of AD plus probability of BD plus probability of CD, right? So now probability of AD is this one. So obviously this cannot happen before this event. So it's going to be 0. Okay, allow me to push it a little bit further here. Okay, so it's going to be 0.4 times 0.04 plus this one 0.45 times 0.03 plus 0.15 times 0.01, right? So when I add those three, what do I get? Okay, so here, this is what I'm getting, 0.00. So the probability is 0.031. The probability is 0.031. This is the probability that a bulb chosen at random from the day's production is defective. So now let's move on to item B. Right. So moving on to item B, guys, you need to be careful. Look for the words or phrase given that. Right. So given that a randomly chosen bulb is defective. So given that the bulb that you're going to draw is defective, find the probability that it was produced by machine A. Right. So this is conditional probability. So we want to find probability that the bulb is defective given that it was produced by machine B. So here, given that a randomly chosen bulb is defective, find the probability that it was produced by machine B, right? Given that it's defective. All right, sorry. So it's going to be this. All right, so here it's going to be probability that it's coming from B, given that it is what? Defective. Right. So here it is simply the intersection, right, over probability that it's defective. So usually this will come from the previous question. So if you get that question wrong, it's going to mess up everything. So make sure you do your calculations perfectly. Right. So now B and D here, it means that the bulb is defective, but it's coming from B. So B and D is this one. The bulb is defective, but it's coming from B. So it's this outcome here. So it's going to be 0.45 times 0.03. So it's going to be 0.45 times 0.03, right, over. So remember what I said, intersection means multiply, that's end, right? Then P of D, it is this probability 0.031, right? So when we multiply that, if you calculate that, what do I get? 0.45 times 0.03 over 0.031. So it's going to be 27 over 62, or it's slightly equal to 0.44, right, to what? To two significant figures. Right, so guys, this completes our solution. Remember, when you see given that, focus only on those outcomes and ignore the rest. Keep practicing. I'll see you in my next video. Take care.